Hey guys, Sebastian from Madrigal here. What you're looking at is the Timbre editor, which is part of a new game audio solution I'm working on called Timbre. I've been working on it for a few weeks now, and I'm pretty excited about it. So, in this video we're going to take a look at what it is, why I made it, why I think it's pretty cool, and finally how and when you can get your hands on it. So Timbre is a node-based system for designing and playing back audio in a game or an app. Lately I've been getting more and more excited about the node-based approach of designing and putting things together, and so I figured I want to create my audio using a node-based system as well. Unfortunately I don't use Unreal, so I can't use Meta Sounds. Meta Sounds is a system that allows you to do just that. But Meta Sounds has worked as a pretty good inspiration for Timbre, in addition to another product that I've been using in the past called Fmod. And I think Timbre is sort of like a cross between Meta Sounds and Fmod, me taking the parts I like from both of those systems. Not that I'm super experienced with either, but a little bit. So let's see, what do we have here? Actually, this music that you're hearing is just played back live through this application. You can see the playback controls up here. We can just pause it or we can stop it completely. We'll go into the node graph in a little bit. Let's see what we have. We have events here on the left. These are essentially your sounds, if you will, things that you can reference from your game. You have a node palette. Very much like in any node-based system, you can just drag something onto the editor and connect it to other things. You have assets here on the left, so these are essentially just WAV files, MP3s in this case. And you have some other windows that we'll go into in a bit. Let's create something super simple and quick to give you an idea. Let's call this Hello World. And like an on start node here, so this is fired whenever the event starts. We'll play sound, so we'll drag a play wave asset node onto the grid. We don't really need to do anything after the sound has finished. We can just let it end. Then we drag a wave asset and we connect it, and now we can play it. And you can see it finished. You can just hit the space bar to have it play, or you can click this play button up here. Does the same thing. Alright, so now you know like 80% of what Timbre is and how it works. So, why did I create something like this when there are perfectly suitable solutions out there already? Well, the reason is that, like I mentioned, I wanted a node-based system, and another reason is that I'm going to release an SDK of sorts of my game engine, hopefully later this year. Not sure about the timeline yet. And as part of that package, I want my users to be able to create sounds for their games using a tool included in the package, so to speak. They shouldn't have to license like Fmod or Wise or anything else. And of course, the best reason of all, the mother of all reasons, it's fun to build things. Anyway, let's go through some examples of what we have here to give you a better understanding of what this thing is capable of. So here we have perhaps the simplest node graph of all time, shall we say. We can just click play. The only thing it does is it prints pi is approximately 3.14. I think I had more decimal places there, but it's rounding them off. So very quick primer for those of you who haven't perhaps used this kind of node system before. You have these things called nodes. You drag them here from node palette, and you can also drag assets like this directly from the asset window. Some of these nodes have these small arrow-shaped pins, as they're called. These are execution pins. So for example, if you have an on-start node and you click play, the execution will start at this and it will go through whatever you've connected it to. So in this case, we have a format print node which prints something, and then it continues, and then it finishes off the event, ends it. You also have data pins. They're these round or square ones. Square just means that this can be connected to multiple things. This round one means that that it can only accept one thing. So basically, what we're doing here is we're printing something. The printed value is taken from this, so we can just put like 1 here, and now if we run this, it will say that pi is approximately 1, which is obviously not true, but just for introductions or instructions sake. And you can obviously change this as well to hello, and now it will print this. So you can see that this is essentially like almost like a generic scripting solution, not just an audio solution. But for Timbre in particular, of course, this is specifically designed to be used with audio. All right, so now we know a little bit about the flow of the graph. Let's look at something else. So here we have something called signals. So let's see what we have. We have an on start here again, and it goes into a repeat node, which every 0.1 seconds does an action. And the action is printing out the value of a sine wave. So here we have a float function. You can select from any of these functions. The value is the time of the current event. So if we play this, we can see down here that 10 times per second it prints out the value of the sine wave, which goes up to 1 and then down to -1 and then back up, as you would expect of a sine wave. And that's fine. Now if we stop this, it just stops, and you can see that the printing has stopped as well. But we can stop this another way, because we have a signal here called stop. And if we have a stop signal, we also get a stop button up here. So the name is just taken from here. If we add something here, stop 1, you can see it updating there as well. So let's undo that. While the event is running, we can send we can send signals to the event. And this is something that the game can then adjust at runtime and send information about the game as it is running to Timbre to let the sounds react accordingly. So if we now play this and then we click stop, not only will we actually stop the event, you can see that it has finished, but we also get this bye-bye message down here. And that means that when we send this signal, it will go in here, it will stop this repeating action. It will then continue through the stopped pin and out here into this bye-bye node. And that means that after this, there are no nodes essentially running, which means that the event just stops. You can see that we don't actually have an end node here. We could add one if we wanted to. We could add like an end here, like this. Bloop. In this case, it doesn't really matter, because when we reach here, it's the only thing that's running, and it's not connected to anything, so it just stops, because this repeat node has already stopped executing at that point. But if we wanted to, we could add an end node here, and it would work just the same. So again, we can see the values getting output, we can stop them, we get bye-bye. So that's signals, a really easy way to do sort of cleanup, if you will, of your sounds. We can imagine that we're playing some sound from this repeat node, and then if something happens in the game, we need to change some parameter. This could be done here in this node before exiting. All right, let's look at something perhaps a little more audible, shall we say? So here we have something called parameters. Let's just see what this sounds like if I play it. So it's just a click sound. if I just hit spacebar, it will play the thing for me. So that's not very exciting. Let's see what happens actually. So we start from on start. We go here, we go to the branch. The branch evaluates and executes, or it evaluates a condition. You can see that this purple connection here is a Boolean value. If the Boolean value is true, it goes here. If it's false, it goes here. And we can hear the click sound, not the alert sound. So it means we went to false. So why is that? Well, we have a parameter called SomeGameValue. And now we can go here to the event parameters and see. Okay, we have a parameter. We can add more here if we want to, but we have one. Its initial value is set to 0.5 and minimum maximum is 0 and 1 respectively. And you can see that when we have this, it actually appears up here, and we can change it here in the editor. And this is of course something that the game can then adjust as well. So if we have it as its initial 0.5 value, it will read the value from here, some game value, and it will check if some game value is greater than 0.75. This is obviously false. And that's why we go to this false one and we play this click sound. But we can adjust this, put it a little bit higher. So let's put it 0.74. Still get the click. 0.5. Hey, now we get the alert instead. So now you can see that as this is running, the game can adjust these parameters by name, some game value, and fire the event again. And you can, for example, you can imagine this being some value in the game that if it reaches like a certain threshold, then you need to be alerted of it. Maybe this is like a damage or something like this. So as soon as it reaches 0.75 or higher, it will play the alert sound instead. And when you go back down, it plays the click sound. And you can see that the event time is much larger for the alert sound, because obviously this alert sound is faster than the click sound. The alert sound is over a second long, while the click sound is like not even 1/10 of a second. All right, but we can do something a little bit more interesting here. Let's add a remap float, if I can type it correctly. Let's add a remap float here, and let's pipe this value into this remap float node. And let's say that as we are above this 0.75 threshold, we want to change the pitch of the alert sound, so that, again, if we consider this to be damage, if we get even more damage, the pitch should be higher and higher. Maybe we could even change the volume of it a little bit, but let's go with pitch for now. So let's remap this from 0.75 to 1 and make the pitch go from, I don't know, 0 to 6 or something like this, and see what happens. So again, 0.5, we get the click. 0.75, we should get the alert. We actually got a click at one point, because even though we were at 0.75, because you might have some like decimal places here messing with you. The minute we go over that, we get the value. But now you can hear that as we are adjusting this, the pitch should be rising. I'm gonna shut up for a bit. And now we go down below it again and we get the clicks. So again, you can see that one parameter can drive multiple things, and we can, of course, we can just drag off any number of things off this guy to make it drive any number of parameters and values in the node graph. So that's pretty cool. All right, so what's next? Let's look at this one. So here we have a few things that we haven't looked at before. We have a repeat node. We've seen this. So when we start repeating something, and we're doing it twice per second. But then we choose a random branch. And this is a way to vary the sounds a little bit. Here we're playing a completely different sound per branch, but you could, of course, just have it adjust some settings that you could then feed into the pitch or playback speed or volume or whatever you want based on the condition. And you can have up to four branches currently. More can be added if needed. So let's look at what this sounds like. Right, actually put the volume down a little bit. We can bring it up a little bit. You can see the float parameter volume, and again we have the volume parameter set here, and it's just piped into the volume. So we have these metal hit sounds, and every time we play a sound, we randomly select one and we play it. So that's not super excited, but it shows you that that you can do things to make the sounds sound more varied right here in the node graph. You don't have to like do anything in the game code. You can just set it up right here and make it sound a little nicer and more varied, more random. But did you notice that when I pressed the stop button, everything just stopped at once? Let's listen to that again. Like when I pressed the button, all the sounds stopped immediately. Because you're essentially telling the runtime, don't execute this graph anymore. Stop all the sounds, cancel everything. We're not running this anymore. And you might not want that. You might want to let the sounds play to the end. And like we looked at before, you might want to do some cleanup. So the way I've done it here, I have this signal called stop the noise, which, as we add it here, the button appears above. It works like this. If I drag an on signal here, it adds a new button for me up there, and I can rename this. And if I make this the same name as the other one, we just get one button, but clicking this button will now fire both of these because they're named the same. Anyway, we have this on signal stop the noise, which when pressed stops this repeat action. That's the only thing it does. But that causes all the sounds that are in flight to finish. We're just not doing anything else. We're not continuing after that. So that means that the event will end because there's nothing connected to these output guys here. So let's look at what that sounds like, and let's compare it to the normal stop. Put up the volume a little bit. So normal stop sounds like this. And then stop the noise. You can see that the time keeps running a little bit because it will finish these sounds before it stops the event. And if it happens to have multiple sounds running, it will let all of those finish before actually finishing the event. So again, this is another way to essentially stop a sound in a slightly different way, you have quite a lot of control over how you want to actually finish the sounds. And of course, that you could do something completely different. Let's put in like a delay here, for example, a delay. So when we stop this stopped pin gets fired. If I can hit the pin, and let's put in a delay of like 2, and then we put in like an alert at the end, like this, right? Like that. So again, we let it play, and if we click stop the noise, it will play the alert sound after 2 seconds, and then finish. So that's pretty cool. Or you can do something completely different. You can do something like if I can hit the pin, thank you very much, and just go back here. I don't need to stop it. So we have the metal bangs. We stop the noise, and then we go back there and then restart the whole thing again. And there's quite a lot of flexibility here, which is pretty cool. All right. So far we haven't looked very much at the actual data pins. We had a very quick look here at this. I mentioned that the square ones are the ones that can be plugged into multiple things. The round ones are the ones that accept only one input. You can see that this is actually not colored. So if you've seen my my video series on the material or shader editor that I made using this same node editor, then you know that different colors mean different types, and yellow means float. So this is a float that comes out of this float node, obviously. This is uncolored because this means that it can essentially accept anything. Like you can plug in like an integer or a string or whatever, and it tries to print it. That's not normally the case. Normally you have something like this, like a remap float node, which accepts floats, unsurprisingly, and outputs a float. Green is a wave asset, and obviously we have this special case, these execution pins that are just execution pins. This is a boolean, etc., etc. And most of the nodes that actually have some sort of parameters, like this period here, for example, you can in many cases set it directly in the node, or you can just plug it in here. So now if we the volume is pretty low, so let's listen to this horrible thing. If I do it like 10 times per second, or I can have it fire it just once per second. Or you can do something completely different, like feed it a curve. So now that we plug this into the period, you see this value goes away because it's now driven by this curve. And so what do we do about this curve? Well, as you can see, we can click to add, and this gives us a curve editor, which we can use to just, what should we do? Let's have it like, I'm just gonna add some points here. So typically what I do is I feed time as the x coordinate, so you can assume that time starts here at 0 and then just moves forward, right? So you can do something like this, something like that, right? So now what we're doing is essentially over about 5.5 seconds, we're adjusting the rate at which we actually fire this repeat node here. We start at about 400 milliseconds, and then we go down, and then we do something like a little bit faster here, and then we go back up to this. can click OK. And now if we run it, this won't work because we still need to plug the time into this. So X coordinate you can see here, and Y coordinate, and this actually doesn't say, but yeah, this is the X coordinate, and or X axis rather, and this is the Y axis. Okay, so let's listen to this. Right, so you could see that it, when it reached this point, it just went like bang 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 bang, and then it went back up. It's a little bit of a contrived example, but you can see that you can just drive this with anything, or we can plug in a sine wave here, or whatever we want. Possibilities are essentially endless. Alright, so the main node from the audio perspective, if you will, currently is this play wave asset node. So I'm planning to deal mostly with wave files and just put them together in interesting ways. This is compared to something like meta sounds, where we're actually using synthesis to create a lot of the sounds right there in the node graph. I'm not sure if I'm going to do that yet. I'm not sure if I need it personally, but we'll see. But for playing wave assets, wave sounds, so web files or MP3s, as in this case, or Ogg Vorbis files or whatever, you would use this wave asset node. And you can see some inputs here that we have. You can adjust the volume, you can adjust the playback speed, you can even adjust the pitch a little bit. And again, I've set these parameters up here, which makes them appear up here, and again makes them available here in this list to select, so you can drive these parameters. We can listen to what that sounds like. So volume is not super interesting, perhaps. So playback speed, adjusting the playback speed naturally also adjusts the pitch of the sound. That's just how it works. But we also have this pitch adjustment here, which doesn't necessarily adjust the pitch in a quite as perfect way, shall we say, as adjusting the speed, but pitch adjustment using this control doesn't actually affect the playback speed at all. So it starts to sound a little metallic as you actually go very far from what it's supposed to be, but you can make some pretty interesting things with this. And just double clicking on it, it puts it back to the normal value, or the initial value. So I think a lot of work still has to be done on this particular node to make it support all the use cases I need for the game audio. But it's coming together pretty nicely, and I haven't really had any big issues with this. So let's talk a little bit about the runtime. So this is obviously just the editor for Timbre. Up here in the file menu, if you click Build Project, we can see here, we can make this a little bigger so that you can see it better. This is a really small project, so it doesn't really contain a lot of things, but we have a few events here. And just like in Fmod, because I really like the way Fmod handles these things, all the events get a path. So event video intro is, for example, this guy here. And you can just copy the path and it will print it out for you. But you get these paths, and using this path you can then refer to these events at runtime from the game. You can create instances of them, and you get essentially all the same controls as you get up here in this bar. So if we have something with both signals and parameters, you get play, pause, stop, you get signals, and you get parameters. You can control all of these things dynamically at runtime. And what it is actually doing when it is building the project, so to speak, is it's creating a couple of files here. It's creating a sound bank file. We just have one, and this is essentially the file that contains all the actual wave assets. That's why it's 5.2 megabytes. The main file, the file that contains all of the metadata and these node graphs, is just 6.6K. And using these two files, you can use all of these events at runtime in the game. So that's how the data kind of flows from editor to game. And the runtime is written in C++, and it is designed for easy interop with Zig, because the SDK that I spoke of earlier, that I'm going to release to the public, is actually going to be programmable from Zig rather than C++. I don't want to expose anyone to my horrible C++ monster of a code base, but instead Zig is the way to use all of these systems. And Zig will be the programming language to actually use to control the Timbre runtime as well. All the audio in this project is powered by a wonderful open source sound library called SoLoud. Let's just bring this in and give a quick shout out here to SoLoud and Jari Komppa, a fellow Finn who created this. So terveisiä sinne. And essentially this means that everything that SoLoud can do, which is a lot, and this has all kinds of really interesting things like speech synthesis and all kinds of filters and other synthesizers, potentially can be done from Timbre as well. So Timbre is essentially just like sitting on top of SoLoud and controlling SoLoud. So that's one thing, and it's worth actually mentioning here that the runtime is actually the thing that is controlling the playback from the editor as well. So when we click play here we can see the curve that's actually bringing up the playback speed in the beginning. We're doing like a mini export when we click play. It takes this node graph, all the assets, so in this case this one that it references, and it starts running the runtime actually on a background thread. So you get essentially the very same output as you would if you were to play this from a game. So no cheating there. The runtime currently depends on Basis for a few things. I might consider making like a standalone runtime version later if there is enough interest, if people want to use this kind of system with their own game engines. But for the time being, it will be sort of linked to Basis one way or another. It uses a few things there that are sort of, I don't want to re-implement unless I have to. Things like serialization and etc. But it shouldn't be super difficult to just make a standalone version of it. And like I mentioned, I'm hoping to release the first version of the Basis SDK, which I'm calling it, later this year, which should give you access to Timbre in addition to all of the other tools in my tool belt. So things like the material editor, which you can see here, which might look actually quite similar, especially if we open like a material like this. You can see that it's actually using the same editor as the Timbre editor, and you get the level editor, and you get the what do I have? All the resource managers and everything. All the fun stuff. Alright. I think we're approaching the end here. In the next video, I'll take Timbre and I will re-implement a sound in the game. It's probably the most important sound in the whole game. As you may or may not know, the game I'm working on, Project Slide, is a vehicle game, a car game. And so the engine sound is perhaps like the most important sound of the whole game, arguably. And engine sounds are kind of tricky to implement because they have to sound different at different engine loads and engine RPMs and all of that. And it has to be very seamless and smooth and everything. So it's sort of a challenge, and I think it's a pretty good proof of concept that is Timbre up to the task or not. And so in the next video, we'll most likely look at that and sort of implement it together on the video and test it out in the game. There are a few things that I need to implement before I can do that. So 3D sound is one. Fortunately, So Loud supports 3D sound. It should support 3D sound pretty good. I haven't actually tried it out, but it shouldn't be super difficult to do. So you can place things in the world. And then we have things like buses, and the whole sort of mixing side of things is still kind of missing from Timbre. I mean, you can adjust volume like this, but yeah, it needs some love and some work. And then a million things in the editor, like filtering here doesn't work, for example, etc., etc. But yes, early days still, but I'm liking this so much already. I think this is just super fun to use and to work on as well. So that's it for this time. Let's actually play our wonderful music again, like we usually do at the beginning and end of videos or video series. Thanks for watching. If you're with me this far, especially, thank you. And a special shout out to all the new subscribers. We've reached 200 and gone past 200 subscribers already. I know I promised a Q&A video when we reach 200 at some point. I haven't forgotten about that. I'm kind of planning on how to do that and what would be the best format for that and everything. But that means that you'll still have time to post your questions if you have any, and I'll make sure to answer those in the video. Anyway, with that, I thank you for your time, and I hope to see you in the next video where we'll play more with Timbre. Thanks and bye.